Okay, this is 8.2 notes, verifying identities and common denominators. So if you notice, I just went ahead and filled in this charts, basic one, summary, the summary of their basic trig identities. And we've done this before in our last lesson, or I think we filled it in twice. You have to know these. So yes, there are two that are repeating. These two are the same. So I think the notes just kind of got that forgotten in there. What I do want to say is that these reciprocal identities also work for, this is also true, oops. Also true for squares. Okay, maybe higher if we have anything that's bigger than a square, that's true, anything. So all those reciprocal functions, I can have 1 over sine cubed theta, and that would give me cosecant cubed theta. So just kind of refreshing our memory and so forth. So the next part we're going to do, if you pay attention to our title, it's talking about common denominators. So let's do a quick review on denominators and adding fractions. So what I want to do is the LCD. So the LCD is going to be 6 for these two. The notes, the way you're going to do the notes on there may look like, okay, I'm taking a lot of steps. I don't need to, but I want to make sure that you see how we do things for when we have to do the ones for trig functions. So I have to multiply this by 3 to make a 6 there. I have to multiply this by a 2 to make that a 6. So I have a 6 on the bottom. So 3 times 1 is 3 plus 2, and that's 5 over 6. Okay. All right, our next one, this LCD is 4. So I put a 4 here. So if you notice that for this first one, I have to multiply by 2. The second one, I have to multiply by anything because I already have 4. So 2 times 1 is 2, and I've just put that 3 there from this one, and I get 5 over 4. I'm going to leave it improper. Okay. Next thing we'll look at is this one. And what would be our, think about what our LCD would be for this one. Remember, whenever you're doing LCD, especially when it comes to having variables and different things, and we're going to have trig functions as denominators, everything for the LCD must be provided. So between the 3 and the 5, that has to be 15. But the x has to be represented. So every time you look at this, yeah, I can see 3 times x and 15x. I can say the same there. So now I'm going to multiply this by 5 and this one by 3. On the bottom, I have 15x, and 5 times 2 is 10, 3 times 3 is 9, and so now we're going to have 19 over 15x. So just a quick review. Okay, so we're going to simplify the following. Remember, we want one single term. Here I have 2 terms, so I don't want those. So the first thing, remember, always do is change everything into sine and cosine where possible. So the secant is 1 over cosine x, and this other one is going to be 1 over sine x. Sorry, there is a typo on this, so I'm going to make sure these are all squares. So that means this has to be a square. Sorry about that. So now let's just finish this out. So I need a common denominator. My common denominator between cosine squared x and sine squared x, that LCD is going to be cosine squared x times sine squared x. So now let's multiply each term by what it needs. This needs a sine squared x over a sine squared x. And this one needs a cosine squared x over cosine squared x. So our denominator will be the LCD. And I'm going to write what I see. So I see it as cosine squared x times sine squared x. Okay, so up here, sine times 1 is just sine squared x. Here's my plus. And then 1 times cosine squared x is just cosine squared x. Now, hopefully when you see things, you see an identity there. So if you see that one, just make sure that you're going, oh, okay, this is an identity. And so we're going to use that to help us to finish. So what's cosine squared plus sine squared? That is actually 1. So we have, I'll go over here a little bit. This goes to a 1. So what do we have? We have 1 over cosine squared x sine squared x. Now, with math, with almost anything, I can decompose this and write the 2 fractions that actually created this 1 fraction. So if I were to rewrite this, 1 over cosine squared x times 1 over sine squared x, now I can take and get rid of that. We don't want a fraction, so we can change it to the things that we know using our identities. So 1 over cosine squared x is equal to, and I'm going to put my answer up here, is equal to secant squared x. 1 over sine squared x equals cosecant squared x. So that's us reducing it down to that. Now, it looks like what we started with, but this is a plus and I have 2 terms. This is multiplying and I only have 1 term. As you do these problems, you want to be careful at how much space that you're taking up on your page that you need room for. You want to do all the steps. The work is part of the answer for these. The next section, the work is the answer. So get used to showing that. So let's look at number 2. We're going to change everything in number 2 to sine and cosine if we can. Okay, so I went ahead and took everything and changed it in terms of sine and cosine. Okay, but we have a fraction over fraction, so usually you can, take the top and multiply by the reciprocal of the denominator, but it's not a single fraction on top. I have 2 fractions, so I have to combine them. So 2 fractions, the denominator is not the same, so we have to find the LCD. And the LCD for these 2 would be cosine theta times sine theta. Okay, so I'm going to change it over here. So I need to multiply this by a sine theta, because I don't have that. And over here I'm going to multiply by cosine theta. Okay, so let's go over here. So I'm going to create my fraction on the top. It's going to be sine theta times cosine theta. And then sine times sine is sine squared theta. Cosine times cosine is cosine squared theta. Hopefully when you see these, you start seeing patterns, or not patterns, the identities in there, and you're like, okay, I know where that's going and so forth. Okay, so but I'm still not done. Let me just make sure I put everything like I'm supposed to. I have a big, because that's just the numerator. So I'm going to bring that denominator over here. Okay, so now we can keep change flip, but I see an identity here, okay? We just kind of did this earlier. Sine squared plus cosine squared, that actually equals 1. So we have 1 over sine theta, cosine theta, all divided by our nice little tangent that we changed. Okay, so now that I have a fraction, complex fraction where the top is just 1 fraction and the bottom is another fraction. So there's several things you can do. So it just depends on what you see. We know if we have something the same as top and bottom, we can cancel this. Well, this can cancel with this because it's multiplying up there, okay? So what does that leave me with? That 1 over sine theta divided by sine theta. So in keeping with my rules, I'm going to go down here, this equals. I can keep the first one the same and then multiply by the reciprocal, which would be 1 over sine. And that equals 1 over sine squared theta. So keep multiplying out as far as you can go so you can change it to something. Now here, I don't want a fraction. I know that 1 over sine squared theta is equal to cosecant squared theta. Okay, here's the second page. We're going to do number 3 and 4. We want to make sure that you're just think about everything in that you do with your algebra, any of your middle school math, like adding fractions and so forth, all applies to any of these type of problems. So just kind of, sometimes it's going to take a little bit of thinking about it. Oh yeah, I got to remember I can do this, I can do that. So just think about those things as we go along. I would, maybe highlight them or something. So something that help us out. Okay, so I have 1 over cosine, 1 over 1 minus cosine, and I have 1 over 1 plus cosine. I'll put parentheses around that because those are binomials. And I can't, they're already in cosine form, so as far as down as I can go. So what I'm going to do now is I'm going to find my LCD. Well, my LCD is what I see in the bottom of both. So it has to be 1 minus cosine theta times 1 plus cosine theta. Okay, so now let's do what we normally do. We know that the denominator has to be the least common denominator up there, the LCD. So we're going to put this here. I'm going to move it up. Don't need it too far down. You don't have enough room. So I have 1 minus cosine theta times 1 plus cosine theta. And then what does the numerator need? So this one over here, the first one, I have to multiply it by 1 plus cosine theta. And over here, I got to multiply by 1 minus cosine theta. I'm running out of room up here. Let me just move over my LCD. Okay. I'm just going to leave it off. I really don't need it. So 1 minus cosine theta times 1 minus cosine theta. You don't have to put the parentheses down. I don't know why I did on that one. But so now if I think about it, it's this whole thing times 1. So that's just 1 plus cosine theta. Same thing over here. It's just this times 1. So there's my plus from here. So plus 1 minus cosine theta. Now everything's in terms of sine and cosine and so forth. So let's do what we can. So in the numerator, if you notice that we have a 1 plus a 1, which is going to give me just a 2. Here, though, this is a positive cosine, this is a negative cosine, so these actually cancel each other out. So all we have is a 2. Now, I want you to pay attention to what you have at the bottom. If you have two binomials you multiply together, and they're the same, one's a 1, same, this cosine theta is the same, but they have opposite signs, recognize this is the difference of squares. Okay, so just to refresh our memory, difference of squares means I have a minus b times a plus b. That equals a squared minus b squared. Now, if you don't see that, then you're going to have to FOIL that. But if you can try and recognize those things that you have from algebra, that you'll be able to do, so that part of the math will not take as much time. So let's look at, now if I look at this, and based on this, my 1 is a, so 1 squared is 1 squared is 1. Minus, and then b squared, which is the cosine theta, so b is going to be cosine squared theta. Okay, now I see an identity because I have that 1 with that cosine squared, so I'm going to change this to sine squared theta. So then I'm going to have 2 over sine squared theta. Now, just kind of like the thing we did up there earlier, I kind of separated maybe the fractions, but you're going to separate the fractions if you can to try and get rid of the fraction. And what I mean by that is that 2, I'm going to change this to 2 over 1 times 1 over sine squared theta. This is what this, okay. So I just kind of separate the fraction. I did a legal math move. If you were to multiply those fractions together, you would get this from over here, okay? So that's what I was able to do. So the reason I want to do that is I want to try and get rid of the fraction, and if I can figure out how to do it with the sine squared, since it's on the bottom, I can use the identities to help me. So 2 stays the same. 2 over 1 is just 2, but 1 over sine squared theta is the same as cosecant squared theta. So this is the reciprocal of the cosecant. And that's your answer. Now again, your work is also your answer. You just can't do, and just give me answer. The work is the answer too. It's part of that. Okay, so let's do this last one before we go into the new section. So here we have 2 terms. Again, change everything into terms of sine and cosine. So I will do this first one as 1 over cosine theta minus, and I just have a cosine theta here. Okay, if I put that over 1, now I have two fractions, excuse me, and I need to make it 1 fraction. So I'm multiplied by the LCD. So the LCD is going to be what I see here. So my LCD is just cosine theta. So now I need to make sure that I multiply every fraction by what it needs. This doesn't need anything because it's, I mean, you can say technically 1 because the denominator is already going to be cosine theta. So you didn't really need to add anything to that cosine or multiply anything to do that. This other one, though, you do. You need to multiply this by cosine theta over cosine theta. So in our numerator, we will now have 1 minus cosine times cosine is cosine squared theta. Okay, there's that identity popping up again. All right, so this is an identity. So now 1 minus cosine squared theta is equal to sine squared theta over cosine theta. Okay, so now I have a sine squared on top and a cosine on the bottom. If I can't change that to tangent right away because square here is on top and this is not a square on the bottom. So cosine's not squared, so you can't use that. So let's separate the fractions into 2 different fractions, okay? Like I see a tangent there, so let's do the first one to be sine theta over cosine theta. Now in order to get a square at the top here, I have to multiply this by sine theta. Okay, so now that I've done that, I put that sine theta over 1. This first fraction becomes tangent theta, and then just a times the sine theta. We don't put it over 1 in. And so there's your final answer for this one. Again, I need to see the work. And then obviously the answer. Okay, let's look at the next part that we're doing. Verifying identities. So this is the proving part of the identities, okay? So what you want to do is that you want to pick one side of the equation. It's okay that if you pick left or right, depending on what you need to do the work on. So the second part of this is, pick one side of the equation to work on, the one with the most work. Okay, we'll talk about that in a second. The second thing about this, the work only on one side of the equation. And step 3 is verifying is the proof is complete when both sides of the equation are exactly the same. So before we get on, a few things to kind of look at. If you look at what we were doing in the prior problems up here, if you notice that these have no equal sign. There's nothing being equal. They only have their expressions only. The difference down here is that we have equal sign. So we have equations. Up here at the top, you do you do all the work and you get one little answer like this, and that's usually it. But over here, it's going to be different, okay? The work is the answer. There's no, at the end, circle what's left. Everything that you do for these problems on verifying identity like we're getting ready to do, the work is your answer, okay? So that's when I look at them, I'll look at that way and see how you did it make sense, and so forth. All right, let's look at number 1. So we have sine x times cosine tangent x times secant x equal 1. So I wanted to work on the left because there's more work to do, and I'm only going to work on the left. And I do this a certain way to help me to make sure that I do not lose my flow and I know exactly what I'm doing as I go. So the first thing I'll do is I will change. This doesn't change. You change everything to sine and cosine if you can, or you think about identities and so forth. So we're going to look at both kinds today, and then we'll do some more next lesson. So the first thing we're going to do with this one, we're going to change it to anything that is not a sine or cosine. We'll change that. So cotangent becomes cosine x, over sine x. And then secant x is 1 over cosine x. And I want that to equal 1. Okay, so I want that to equal this 1 over here. So what I do is I just put an equal sign, and then I just keep going. Just to tell me that, look at the left. If you want to, you can write the 1 down every single time, but you don't have to, as long as you're doing the right moves, I guess, my math rules, apply the right rules and so forth. So let's look at what we can do though. If I put this over 1, I hope you can see if it's the same, and they're all being multiplied, right? All these are being multiplied together. That means I can cancel what's on top and the bottom exactly the same. Numerator, this goes to 1. This sine x goes to 1. Now this next one, I can do cosine x goes to 1 because I'm dividing by cosine x, and I get this one as cosine x. So if you notice that all I have is 1 times 1 times 1. Well, that's just 1. Okay, so now I'm going to bring my 1 over here. Does that equal 1? Yes. Okay, so this is complete. A little check mark here, and you did it. So what I want you to think about is it wasn't much work on it, which is fine. Some are going to take longer than others, and that's okay too. So this whole thing that we have going on here, all of this is the answer. All this that I see is the answer down to this. That's the only way you can do that. Notice we didn't get one single answer that we can just say circled because the equation, right? They're exactly the same. The other thing I want you to think about though too is when you do get your final answer here, okay, this has to make a true statement. Okay, this has to be true. Okay, for this side, it doesn't, this number 2, if I look at it, both sides have work that I want to get done, okay? So you choose a side that you want to do. I'm going to choose the left. I'm a person that chooses the left, but I also will show you if you chose the right. Okay, it doesn't matter. So one person that you're working with may do one way and you do another way. There's still the steps. Should all the things that you substitute and you do the math correctly should be the same for both y'all. So when I chose the left side, when you do this, well, you want to think, I have a sine squared here, but I need a cosine squared here. I have a 2. I see that 2 right there. This is a minus 1 over here, so I have to create a minus 1 somehow. So what we're going to do is we'll just go using the left side only and talk about using identities and so forth as we go. This is not a difference of cubes because of that 2. So what I'm going to do is I'm going to have to just substitute. What can I change this sine squared x? Well, I know sine squared x is equal to 1 minus cosine squared x. So that's what I'm going to do. So I'm going to bring down this 1 minus 2. And then what I'm going to change that to now is 1 minus cosine squared x. So that's exactly, okay. Now this side has to be equal, and I want to equal this up here. So let's see if we can get that. I see the cosine squared x and I see a 1, but it's not quite that same thing. So let's keep going. Mathematically, we would just always distribute to get rid of the parentheses. So this is going to be 1 minus negative 2 times a positive 1 is a negative 2. Negative 2 times a negative cosine squared x is a positive 2 cosine squared x. I'm just going to put an equal sign here because I still want to prove that what's on the right. So it's getting there. I have a 2 cosine squared, so now I just need this minus 1 here. So let's just combine like terms. I know 1 minus 2 is negative 1, plus I don't get to do anything else. Okay, so I'm getting there. So now it's exactly this way, but it's not written exactly the same. So we're going to change this to look like it's supposed to. So I've just changed these two, and that's what I get. So that does equal, and yes, I want you to bring down this, what I'm doing here. These are exactly the same, so this is true. Okay, so now I'm going to use the right to prove the left, okay? So then, again, this is going to be just another way so that you can see that it does work for both ways. So I'm going to do the same thing. I cannot, that again, this is not a difference of squares. So I need to change cosine squared x to 1 minus sine squared x. And then I have the minus 1 on the outside. Same thing as we did before. We have to distribute the 2. So we have 2 minus 2 sine squared x. And then we have the minus 1. So let's combine like terms. We have a 2 here and a negative 1. So that gives us 1 minus 2 sine squared x. So now that I see it's exactly the same, I'm going to bring this other one down here. And this is going to be 1 minus 2 sine squared x equals 1 minus 2 sine squared x. So this is done. So just to reiterate that this is the answer, all this is the answer. If you did it the other way, all this is your answer.